All right. Good morning, everyone, and thank you for joining today's new product update webinar topic, the AFE 8190, the industry's first 16-channel RF transceiver. My name is Simran Nanda, and I am the product marketing engineer for the wireless infrastructure team at Texas Instruments. Before we get started, I would like to encourage you to ask questions throughout the presentation using these on the right side where we have Jenny as well, our system engineer, to help answer any questions. And we will conduct a Q&A at the end of this presentation. All right, let's get into it. So today, we will be talking about a few different items here. So first, I will discuss the core features of the AFE 8190 transceiver, and following through with key RF performance results and common use cases for this device. The AFE 8190 for mainly massive MIMO applications, as well as private network and SATCOM. And finishing up with hardware and software resources for evaluation. Okay, so the AFE 8190, which was released recently, is our 16 transmit, 16 receive, and 4 feedback RF transceiver, mainly designed for wireless infrastructure applications. And as a block diagram of the chip itself, which is a 23 by 23 millimeter squared chip. It has an RF frequency range of 400 megahertz up to 7.2 gigahertz to accommodate for N104 band use cases. In terms of the RF signal bandwidth, the transmit and feedback channels can operate up to 880 megahertz, and the receive can operate up to 600 megahertz. For the direct up conversion and down conversion support, we do have single ducts and DDCs that possess up to the 600 megahertz RF signal bandwidth. In terms of the digital data interface, this device supports JSD compliant 204B and C support, possessing 16 SerDes transceivers that can operate up to 32.5 gigabits per second. Involving both 8-bit, 10-bit, and 64, 66-bit encoding. This transceiver can also fit for either a 12-bit, 16, 24, or 32-bit resolution, depending on the need, and also has the subclass 1 multi-device synchronization capability. Looking at the RF DAC side, the interface rate goes up to 12 gigasamples per second and does have support for both the first and second Nyquist OS for sampling. And this transceiver does have both straight and interleaved modes as well. And one of the key features on the DAC side is the power amplifier protection, or PAP circuitry, which does help protect the PA from abnormal signals or any coupling that may be seen when transmitting. On the RF ADC side, it goes up to 5 gigasamples per second with a higher rate than our previous transceiver generations for flexible frequency. This transceiver has an integrated digital step attenuator, or DSA, with optional automatic gain control functions, depending on the power level of your system. For further device reliability protection, this transceiver also has integrated RF overload detectors. So really, to sum up the key features, right, this transceiver, and I will also now go into our portfolio in a second, this transceiver does possess a wider RF frequency range compared to the previous transceivers in our portfolio, as well as, of course, wider and the high channel count to accommodate for those more robust applications, which can include massive MIMO, satellite communications or SATCOM, military 5G, private network, and also or fixed wireless access. And one comment for clarification here, that while SATCOM is one of the applications that is mentioned here, this device is not explicitly been tested for radiation or could be labeled space grade. Just to make that clear, this would of course be integrated more so for those ground communications. All right, moving on to our portfolio to just give a little bit of a background on wireless infrastructure. So our team has been working really in this space for over, and recently we started designing RF integrated receivers. One thing to note about our portfolio, really starting from left to right, as you can hear, with almost every generation, we increase the channel count as well as the frequency range and signal bandwidth. Some of the applications that have not been listed for the 8190 do include small cell, which our AFE 76, 77, and 79 families are really designed for, as well as macro, repeater, and DAS systems, which is really where the majority of the portfolio for, as well as massive MIMO, which is the main discussion for today. But a couple of notes on our portfolio. So TI was actually first to market for the 4-channel, the 8-channel, and recently the 16-channel RF transceivers. And really to highlight, the AFE 8190 is, of course, the latest installment in our portfolio, where we're investing continuously for 5G and beyond. And all of our transceivers are either the 0IF or the RF sampling. The majority of our portfolio is direct to RF sampling architecture, but there is one slight exception in our AFE 77 family, which was meant to accommodate for a wider bandwidth at time. And so one other device to highlight here as well, speaking of the more recent ones as well, is the AFE 77 XXD, which is a 4-channel RF transceiver, but with integrated digital pre-distortion. Okay, I will go ahead and move on to if there are any questions regarding the portfolio, please feel free to drop them in the chat and we will answer. So going back to the AFE 8190, so of course the sample rates that are supported here is up to 12 gigasamples per second on the DAC side and 5 gigasamples on the ADC side. So one note, so previously the majority of our transceivers support 12 gigasamples per second on the DAC, but on the ADC side, our previous generations do support up to 3 or 4 gigasamples per second. And once again, the massive MIMO and other robust applications, and for more flexible frequency planning as well, we have installed a higher ADC rate for this device and for the device family as well. And so as you can see here, there are 2 different tables for both sample rates. And in terms of getting the access to the data sheet, you can request so on the AFE 8190 product page if you search for this device on TI.com. And so moving on to one of the RF performance plots that you can see here. So here is basically a complex FFT plot of our AFE 81 that clock frequency of 2949 megahertz. And so this is just one example of one of the clean signals that we have of our 8190. And this is really just the transmit signal performance. And once again, that frequency planning that we are able to accommodate for in a sense. And so to dive a little bit deeper into one of the main applications, so as mentioned before, the AFE8190 is primarily designed for wireless infrastructure. On the side, we do have a different team that does specialize in more of the aerospace and defense applications that also designs analog front ends, but this is really to showcase a massive MIMO application. AFE8190 is in production today with several customers. And this is just one of a few different use cases that we come across for massive MIMO applications, where either from 30 up to really 256 transmit receive, you have the ability to basically stack multiple of our AFE8190 transceivers together in one radio to basically accommodate for the channel count requirement. And so looking at the left here, right, we have a couple of different design parameters, and this is just an example of use case. Some of the popular frequency bands that we do come across can really, on the 5G side, can really range from the N77, the N78, even going higher to that N104. It really depends on the customer application and location, of course. But this device is extremely flexible to accommodate for, once again, that full range of between 400 megahertz up to 7.2 gigahertz. And so for this specific application, you can see that the frequency band chosen is between 3.4 gigahertz and 3.8 gigahertz. And the instantaneous bandwidth chosen here is specifically 400 megahertz. Now, while this device does not have integrated digital pre-distortion or DPD to linearize the power of a radio, this does include a DPD expansion bandwidth for the 4 feedback channels in each transceiver, a DPD expansion bandwidth of 800 megahertz, should that be an option for your design. For this specific design, the PLO reference clock recommended will be that 491.52 megahertz with using the maximum FPGA and SerDes rate of 32.5 gigabits per second. The JST204 mode either can be, of course, 204B or 204C. And in this specific case, the 64, 66-bit has been chosen. And in our full data sheet, which of course you can request, we do have additional power supply recommendations and also filtering recommendations and data to really have reference points for you in terms of designing your massive MIMO or other application to ensure that everything lines up from the transceiver perspective. Some of the additional design cut and considerations can including a low pass filter to basically to minimize that impact of the aliasing process that can happen within the system. And additionally, using the minimum number of SerDes lanes for that optimal power efficiency. Of course, power consumption is a huge care about for a lot of RF radio systems. And so that is one thing that is definitely implemented in our transceiver. And so on the right, of course, you can see this example block diagram where there are basically 2 separate systems, including separate parts of the AFE8190 integrated together for a 32 transmit, 32 receive massive MIMO application. And so going back to the RF performance of the 8190, when it comes to the transmit adjacent channel power ratio, or ACPR, looking at the same use case with just the AFE alone, this is essentially the output on the transmit side, as you can see, where the we're basically the ACPR is pretty low, around that minus 56, 57 dBc or decibel to carrier range. This is for, of course, by 100 megahertz bandwidth use case of that 3.4 to 3.8. But this, of course, can be modified, and we have additional plots or data sheet should you be interested in a different kind of use case for your system. So in terms of design and development, if one is interested in leveraging our evaluation module for a massive MIMO or a private 5G system, we do offer two different boards to really help with the evaluation process. So on the starting with the hardware side, we have our AFE 8190 EVM, which is on the left side here. And this is today on TI.com if you do search for it. And this EVM paired with our capture card on the right side here, also known as a TSW 14J58, does support, of course, JST204B and C protocol. These two boards can be interfaced together through an FMC connector. And this software 81 can be used for that initial configuration and design and development of your system. And so as you can see here on the screen, there is basically a screenshot of the main graphical user interface window of our AFE 81 software. This essentially, of course, there's a lot going on here, but this is essentially the configuration homepage where you can select a certain number of channels, whether it's a few or all, and design your configuration file to program your AFE 8190 accordingly once the boards are connected to your respective PC. On the bottom side is, of course, the method to customize the channel configuration. And of course, looking on the right side here, there are options to, once after selecting the different configuration parameters, being able to load and save your configuration file. And at the bottom, we do have a device bring up or a device configuration button, which will basically be utilized once your configuration file is loaded into the software to basically wake up your AFE and design it and program it for those specific parameters. This software is available today in that same design file request package if you do search for either the AFE 8190 IC or the evaluation module, where you will be able to request for full access and download this software for free. One additional point before I do conclude is, second. Okay, I guess it wasn't shown here. But one additional point that I would like to also add here is that next month, our team will be at the International Microwave Symposium, or IMS, in San Francisco, California. This will be the week of June 15th, where we will actually be demonstrating our AFE 819X device with a capture card to basically demonstrate a wider signal bandwidth of over 1 gigahertz of bandwidth for these kinds of applications, and also showing JST204D SerDes interface. So we will be at booth 355. If any of you happen to also be attending, please come check us out. Oh, it was here. So this is just a little bit more information on what to see in mid-June of next month. And so that really concludes this webinar. I want to thank everyone for joining today's new product update on the AFE 8190. If you have any additional questions, please put them in the Q&A box, and we will be sure to reach out to you directly. Also, be sure to visit ti.com/NPU for all of our upcoming topics, as we do showcase different webinars on new product updates every Thursday at 10 a.m. Central Time. And we look forward to seeing you all again next week.